So here are the answers for each of those. You can pause again to take a look at the answers, compare each one. If you have difficulty getting any of them again, mark it, contact me, we'll go over it together. Next, I want to talk about similar polygons. Let's discuss what it takes for a polygon to be similar to another polygon. We're looking at some triangles right now, and these triangles are similar to one another because two of the angles of one triangle are congruent to two of the angles of another triangle. So these don't have the same dimensions, the same length of sides, but the angle measurements are the same. They're not congruent triangles. They don't have the same measurements, but the angles are congruent. There's a proportionality between each of the sides because the angles are congruent. And the first one is this angle-angle similarity is the first way to determine whether or not these triangles are similar to one another. So if we know that P and T are congruent and Q and S are congruent, then we know that these triangles are similar. Notice this little symbol here is the little mark that goes over our equal sign for congruent, but these aren't congruent triangles, they're similar triangles. So next, we'll take a look at a couple of different ways to determine similarity as well. Notice that these look very similar to our congruency rules, but rather than congruency, these are similarities. We have the side-side-side similarity, which is the measures of the corresponding sides of two triangles are proportional, and then the triangles are similar. So we're comparing the sides. We take a look at which sides compared to one another. We've got PQ and ST. Don't ask me why they decided to go a different direction on each one. It bothers me. They're not supposed to do that, but for whatever reason, when they wrote this example up, they did. Let it bother me, don't let it bother you. So PQ over ST equals QR over SU, and then RP over UT. So it's got all of the sides compared to one another, and if we had values for these, we could see if these fractions actually equaled each other, and if they did, then they would be similar triangles. Now that doesn't mean that the lengths actually equal each other, it means that those proportions come out to be reduced to the same amount, and we'll see that in a couple of problems soon. But the next one, the final one here, is the side angle side similarity. So we're doing the same thing with each side, but we are only taking two of the sides instead of three, and we're taking an angle that's in between those two sides as congruent. So that if we have two of the sides that are proportional to each other and a congruent angle, then we can determine that it's similar through the side angle side similarity. Again, these are not congruencies, but similarities. So let's take a look then at what that really means next. So similar polygons have the same shape, but not necessarily the same size. And it wants us to start by listing all the pairs of congruent angles and writing a proportion that relates to the congruent sides. Here in example 1, so it's listing angle A as congruent with X, B as congruent with Y, C as congruent with Z. And then the proportions for the sides, we've got AB over XY, BC over YZ, and CA over ZX. And again, if we had the numbers for these, then we could easily take a look. Are these angles actually congruent? Are these sides actually proportional? We're going to take a look at that in example 2 here, using a different figure than a triangle, but we're given here the ability to determine whether the figures are similar and to write a similarity statement. So it's comparing each of the angles. We look at each of the angles and we can see our little congruency marks here. We've got one little arc here for W and for P, meaning those are congruent. We've got 2 at Z and S, meaning they're congruent, and 3 and 4 and so on for each angle. So yes, there are congruent angles in each of the figures here, and here's a list of how they're congruent to each other. Then when we compare the sides, we've actually got the length of these sides this time. So when we start with side WX over side PQ, we've then got 12 over 8, which can be reduced to 3 over 2. Here's the 12, here's the 8. These are the two sides, WX and PQ, 12 over 8, reduced to 3 over 2. Next side, XY and QR, 18 over 12, can also be reduced to 3 over 2. YZ and RS, 15 over 10, can also be reduced to 3 over 2. Then it's going for ZW and SP, 9 over 6, 3 over 2. So if you look at every single side here, they can all be reduced down in their comparisons and their proportions to one another to 3 over 2. That remains constant, so we know that these are similar figures with a scale factor of 3 over 2. Now, what would we do if one of these sides didn't work out? One of these comparisons did not work out to 3 over 2. Even though we know all these angles are the same, so they should be proportional, what if the values that they gave us were wrong? They gave us something that was different here, and one of those sides didn't work out to 3 over 2, then we could mark it as not a similar figure. We know that they're giving us a curveball there, trying to get us to think that we have a right answer when we don't actually have a right answer. So when we're comparing them, if we didn't have the angles, we just had the sides, we could compare them, we'd get these same answers. If one of these sides was different, we wouldn't get 3, 2 on all of them, and then we'd know we didn't have a similar figure. Since they're all working out to 3 over 2, we know we have similar figures. Okay, so some easy exercises here. It wants us to list all pairs of congruent angles and write a proportion that relates the corresponding sides of each pairs of polygons. We've done this in the examples, we've looked at these, so look back to those examples if you need some help there. All you need to do is list out each angle and which angle is congruent with in the other triangle figure here. If you're having trouble figuring out where to start, compare DEF to GHJ. So D is to G, so D, G. These are the two angles that go together. E, H, F, J. So these are similar triangles, we're told here. So write out each of the corresponding angles and then corresponding sides in the same way. So D, E over G, H equals, and then do all the rest of the sides in the same way, continuing to follow the same line there. Do the same thing for these figures here, listing out the angles, listing out the sides. Then when we get to 3 and 4, we're asked to figure out whether or not these are similar figures. Well, we can figure that out really easily. We look over here and we have a regular shape, and over here we have something different. So there's a right angle over here and an angle not marked, and it's not equal to all the other sides, even though this one is. So we can kind of look at this and know right away, okay, these are not similar figures. Why not? Explain your reasoning. Well, if we're looking at side comparisons, then we know that not all the sides are congruent. If we're looking at, not all the sides are proportional. If we're looking at angle comparisons, then not all the angles are congruent. So write that down on your sheet of paper. You are supposed to be writing this down on your sheet of paper, again, to take a picture and send in to me later. Here, number 4, don't let this one fool you. There are two triangles here. One small one, PQR, and one large one, PST. Even though they're drawn on top of each other, they are two separate triangles. They are similar figures, or are they? Well, we're given that P here is congruent with P, and then we're shown each of the equivalent sides of the triangles and how they measure out. Here is a midsection here to the triangle, which forms the base of another triangle. All right, so you can figure out the sides and write out the sides and the angles and what you're going to do to determine that there. I'll let you write that out on your own sheet of paper for turning in later. Let's move on to using similar figures. Using similar figures, you can use scale factors and proportions to find missing side lengths of similar polygons. So the two polygons are similar, find x and y. So here we've got all of our congruent angles and we're looking for the way to find x and to find y. So if we're going to write it in a proportion, we're really just skipping ahead from what we've seen in the examples and just going straight into the numbers, not even worrying about writing down the sides as proportions yet. But we're taking this 32, finding the side that it corresponds with. We can tell that from the angles. Here's the third arc mark. Here's the third arc mark, single arc, single arc. So 32 corresponds with 16 here, so it's 32 over 16. And that equals, we're looking for x over 13. So then we cross multiply, 32 times 13, x times 16, we get 16x equals 32 times 13. We then multiply that out and divide both sides by 16 to get x equals 26. We do the same thing for y over here, getting our proportions set up, cross multiplying, and figuring out that y equals 19. So that's how we can use cross multiplication there to try and figure out the length of the sides that are missing, each variable there. What about when we've got only one of the sides? Here in example 2, we're given two similar triangles, and we're told all the sides for one of them, but on this one we've only got the measurement of one side. So our scale factor here, we're taking EF over HJ, because we have the measurement of HJ, so we look for the corresponding side here, and we have 8 over 12. Well, we can reduce that to 2/3, 2 over 3. That's our scale factor for each of the sides. We're already told that these are similar figures, so we don't have to worry about figuring out if they're similar or not. And we're trying to figure out in this problem the perimeter of each of the triangles. Well, the perimeter on this one's pretty easy because they've given us all three of the sides. So 10 plus 8 plus 12 equals 30. So this triangle has a perimeter of 30. So we've trying to figure out the perimeter of this one where we don't have the sides, but we can figure it out using our scale factor. Our scale factor of 2/3 is equal to, and we're setting up another ratio over here, of perimeter of one of our figures over the perimeter of our second figure. We've figured out the perimeter of one, so we've got 2/3 equals 30. We're looking for the other, which is x. So 30 over x. We cross multiply, 3 times 30. We get 2x on the other side. Once we multiply that out and solve for x, we get x equals 45. The perimeter of this figure here is 45. So let's move forward. Taking a look at some more practice problems here. We're doing the same thing. We're solving for x. We're figuring out which sides correspond to each other, set up our proportions, cross multiply, and then solve for x as it comes up here. So make sure to pause here,